Hi, I'm Jeff Cogswell. Today I want to talk a little bit about what vectorization is and how you can get the most out of it. I'm going to be using some figures that are complements of James Reinders and Jim Jeffers from their book Intel Xeon Phi Coprocessor High Performance Programming, which you can find out more at lotsofcores.com. Okay, let's start with an example. Here we have some C code up here. We have three arrays, A, B, and C, and max is some predefined variable. For now, we're going to just treat max as the number 16, and in a moment we'll take that higher. Now we have a loop here that goes from 0 to 16, and it takes the value of the first element in A, adds it to the first element in B, and stores the result in the first element in C. Then it does it again with the second elements, and third, and so on through 16. Now when we use just regular serial programming, the processor will do the first iteration, adding the 2, save it, and then do the second after the first is complete. And it'll do 16 in a row, one after the other. Now with a technique called vectorization, we can have the processor do 16 of these simultaneously. Now this depends on the type of processor you have. For this example, they're working with a processor that can handle up to 16 single precision floating point numbers. Many of the processors we use right now do half that, but that's okay. For this example, we'll go with the 16. Now here we have what are called registers. These registers exist right inside the processor, and they behave very much like memory, but the processor can directly access them. And so what we do is we take our entire array of 16 single precision floating point numbers, and we copy the entire array A into this first one, and we copy the entire array B into the second one. Now the processor, using what's called vectorization, can actually add all 16 of those numbers in one operation. So over here on the right hand side, we have the first element of A will get added to the first element of B, and the answer will get put in the first element of C. And we have 16 of these across, and the processor with a single operation will add all 16 of these elements to their corresponding elements in B and save all 16 answers in the corresponding positions in C. That's what vectorization is. Now this example, we use single precision numbers. If we had used double precision numbers, those numbers take up twice as much space, so we can fit half as many inside each register. So in that case, we would fit 8. Now with this example, we're only doing 16, but if we do more than 16, the way it works is first we do our first 16 numbers, finish it up, and when we're done, we copy the 16 answers from C back into memory. Then we do the next 16 in the array. Copy 16 in for A and B, do the addition in one operation, and copy it all back. Now the processor can easily copy this memory quickly in and out of memory, so we don't actually loop through each one copying it in. It all does it in one shot. And that way we can do 16 at a time. So if we do, say, 32, we can do it in 2 operations, and so on. And that's basically how vectorization works in a nutshell. There's so much more to say about it, and in future videos I will show you much more.